Welcome to Crisis in Perception, where we examine the systems shaping our world one book at a time. We are diving deep today into Noam Chomsky's interviews, compiled and framed by James McGillivray in The Science of Language. In this book, it takes on one of the oldest, most profound questions there is, really. What fundamentally distinguishes human beings from every other creature on the planet. But it explores it using the very precise, demanding tools of modern biological science.
And the answer, which, really sets the entire agenda for this deep dive, is that the key lies in language.
Right.
But, and this is crucial, not in the everyday sense, not language as a tool for, external conversation or social stuff. Chomsky argues the defining feature is language as an internal computational system, something that's actually in the mind and the brain.
So it's the hardware.
It's the hardware that enables our unique form of thought.
Exactly. And that changes the whole game, doesn't it? Because if language is the biological mechanism that explains our distinctiveness, if it's the bridge between our physical bodies and our abstract minds,
then studying its structure is, well, it's the most essential path toward understanding everything else that defines us. Our unique capacity for science, for abstract morality, for complex math, for planning way into the future.
And the source material really leans into this. It suggests that the sudden introduction of this internal system is what powered the, quote, great leap forward in human cognition.
Right, the one that the archaeological evidence places somewhere around, 60,000 to 100,000 years ago?
An evolutionary instinct.
Exactly. So this isn't just about parsing sentences, it's really about defining human nature. If this core computational mechanism of language is, as simple and innate as the theory suggests, it suddenly explains why all these distinctly human things, art, complex tools, navigation, just seem to explode onto the scene.
With no long, gradual buildup.
None. It means the biological architecture of our minds imposes both these really rigid limits and, at the same time, this unbounded creative capability that defines what's possible for a human.
So our mission in this deep dive is a systems analysis. We're focused on that biological architecture. We're going to try and dissect the simple, elegant internal mechanism that Chomsky posits is called merge, and analyze how this one computational constraint imposes both extraordinary creative freedom and, predictable biological limits on our thought.
And it does all this independent of culture or your environment. It's an exploration of the biological necessity behind our freedom.
Okay, let's unpack this.
So to really get the arguments in the science of language, we need to set the stage a little bit, historically and intellectually.
The players involved.
Right. We have two key players.
Yeah.
First, Noam Chomsky. He's an institute professor, retired at MIT. And it's really not an exaggeration to say he virtually created the modern science of language when he introduced generative grammar way back in the mid-1950s.
His views are, well, they're notoriously difficult to track, partly because they weave together this really dense technical linguistics with philosophical critiques and, of course, his broader political commentary. So it's important for us to say right up front that for this deep dive, we're focusing strictly on the science of language content, the linguistics, the cognition, the philosophy of mind as it's presented here.
And the second player is James McGillivray, who is a professor of philosophy at McGill University. And he's absolutely crucial here. He's the interviewer, the philosophical guide, really.
The interlocutor.
Exactly. His role in this book is vital because his commentary and his framing, his careful questions, they're all designed specifically to make Chomsky's sometimes very technical and iconoclastic ideas accessible to someone who isn't a specialist.
He's steering the conversation away from the really deep weeds of linguistics unless it's absolutely necessary for clarification.
He is. Now, the book itself, The Science of Language, it's based on a series of extensive, pretty informal discussions and interviews that happened back in 2004.
With a key follow-up, right? In 2009.
A critical follow-up in 2009. And that later session focused very heavily on this, provocative claim that the language faculty might be perfectly designed. It's a concept we're definitely going to dig into.
And McGillivray organized all of this into two main parts, the science of language and mind, and human nature and its study.
Now, the theoretical context for all of this is what's known as the Minimalist Program, or MP. This is a research agenda that Chomsky and his colleagues developed, starting back in the early 1990s. And if we connect this to the bigger picture, the MP is a really profound shift. It's a radical search for theoretical simplicity, for explanatory depth.
So what are they trying to minimize exactly?
They're trying to radically simplify the theory of universal grammar, or UG.
And UG is the idea that we're born with some innate knowledge of language structure.
Yes. The fundamental goal of the MP is to figure out how much of language structure can be explained not by specific genetic code, but by, general computational principles or external physical laws, what they call the third factor, and also just the requirements of how language connects to thought and to sound.
The interface condition.
The interface conditions. The whole idea is to leave only a minimal, absolutely necessary language-specific component. And this effort leads to the hypothesis that maybe the entire genetic contribution is just one simple recursive operation called merge.
So the whole intellectual incentive is to find the most elegant, the most efficient explanation possible. If we strip away all the jargon, what's the book's central through line? What's the one conclusion they want you to walk away with?
It's this. Language is an objective, biologically based, natural object, not a social institution. Chomsky calls this the I language.
I for internal, individual.
And intentional. And this I language is a cognitive organ. It grows in a person according to an innate agenda, much like a physical organ, say, your visual cortex or a kidney develops. It's dictated by the human genome and by biophysical constraints.
So the study of language, then, has to be framed as biolinguistics, a natural science.
Exactly. A natural science like physics or chemistry, it just differs in its subject matter and, its experimental techniques.
And that sets up this huge contrast with the common sense view of language.
A massive one. Because the common sense view is what Chomsky calls e-language, external language.
So that's English, French,
Yeah.
the languages you learn in school.
Right. It's defined as a set of social practices or behaviors or just a big collection of sentences. Chomsky sees this e-language as just a phenomenon. It's the messy surface data that results from the internal system, but it's fundamentally unsuitable for scientific study because it's just so full of historical accidents and social variation.
Okay, let's jump right into the core claims then, starting with the one that really challenges almost everyone's intuition. The idea that language is for thought, not primarily for communication.
This claim is, it's rooted in resisting the idea of defining something by its presumed function. Chomsky argues that defining language by its use is a category error.
Because it's a complex biological system. It has many functions.
It has many functions. He uses a great analogy of the human skeleton. If you ask, what's the function of the skeleton, you might say, well, structure or movement.
Right, keeping you upright.
Sure. But the skeleton also stores calcium. It produces blood cells in the marrow. It protects your vital organs. Which one is the function? It entirely depends on your current biological interest, It's really hard to assign one single defining function to a complex biological part.
And when you apply that same logic to language, the focus just immediately shifts from external speech, which is this tiny, observable surface phenomenon, to the vast internal world of cognition.
Precisely. I mean, if we look at its actual use, probably 99.9% of language use is internal. It's in the mind.
We're constantly talking to ourselves.
Constantly. We're formulating, refining, interpreting. It's an act of incredible cognitive effort not to talk to yourself. The externalization part, the sounds or signs that come out of your mouth or your hands, that's a tiny and actually pretty effortful fraction of the total linguistic activity going on.
Even that tiny external fraction, the sources point out, isn't really communication in the strict sense of conveying new, meaningful information a lot of the time.
That's right. I mean, just think about a cocktail party or casual office chatter. The amount of verifiable, meaningful, novel information being passed back and forth is often minuscule. People are mostly using language for social bonding or expressing emotions or just, maintaining a presence.
So language is used for communication, but
so is your body odor or your posture or the clothes you wear. So communication can't be seen as the fundamental defining function of the computational system itself.
And this internal focus, it leads to a really profound and actually highly simplified model for how language might have evolved.
The sources outline this evolutionary priority. Language likely evolved because the genetic mutation that created the core recursive operation gave an internal selectional advantage.
So the ability to think in complex ways.
The capacity for complex thought, for detailed interpretation, for long-term planning, all of that relies on being able to structure and store information hierarchically. And here's the key biological detail. Mutations happen in a single individual, not a group.
Okay, so let's picture a small breeding group of early Homo sapiens, say 80,000 years ago. One person has a slight genetic rewiring that enables this new recursive operation.
Right. And that person and then their children suddenly have this incredible internal advantage, the capacity to plan a hunt 5 months from now, or to structure a belief system about the universe, or to interpret really complex social signals.
And this provides an immediate internal benefit. It's useful to that individual long before externalized speech became highly codified or necessary for the whole group.
It's the simplest assumption that fits the evidence of a sudden, saltational, evolutionary jump, a rapid, non-gradual appearance. This explosion of complex symbolic thought, which, soon led to cave art, intricate tools, notation for astronomical events, complex social organization. It's just really hard to imagine that happening without language. And most of that enabling activity, the planning, the interpretation, is fundamentally internal.
Which brings us back to that formal distinction that you said is the foundation of modern linguistic science. I-language versus E-language. We covered the basics, but let's go a bit deeper into the technical difference, especially why I-language is called intentional.
So I-language is the proper objective subject of linguistic science. It's the steady state of the mental language faculty in a person's head. Its properties are determined by two things: the innate universal grammar, which is fixed by our genome, and fundamental biophysical constraints, which is what makes it a subject for naturalistic science.
And the term intentional.
Right, intentional is crucial here. In philosophical logic, the intention of a set is the rule. It's the defining characteristic that specifies what gets to be a member of the set. The extension, on the other hand, is just the list of all the members.
Can you give us a quick analogy?
Sure. Think of it like this. If I ask you to define prime number, the definition, a whole number greater than 1 whose only factors are 1 in itself, that's the intention. That's the rule.
And the extension would be the infinite list, 2, 3, 5, 7, 11, and so on.
You got it.
Okay, so I-language is the biological mechanism, the rule set, that generates the infinite potential of human language.
Precisely. And E-language, on the other hand, is the extension. It's the common sense notion of English or French defined as the set of all possible sentences or social practices. And since that list is infinite, and since the observed data, the E-language is always messy, partial, and riddled with historical accidents.
Like the impact of the Norman Conquest on English vocabulary.
Yeah, exactly. The Norman Conquest tells us a lot about history, but nothing about the innate language organ, so you can't study it scientifically as a natural object. Only the I-language, the rule set in the head, can be studied scientifically.
In this necessary focus on I-language, it mandates what the book calls a nativist or rationalist stance, which is, well, it's often controversial in fields that study human behavior. Why is this stance absolutely necessary for Chomsky's framework?
Because of this famous observation known as the poverty of the stimulus, this is the core mystery that really forces the rationalist conclusion.
Okay, what is it?
It's the fact that children acquire the full grammatical complexity of their language, including really subtle, abstract principles, quickly, automatically, and uniformly. And they do this regardless of their general intelligence and, crucially, despite receiving limited, corrupt, or inconsistent data from their environment.
So the input they get is just not rich enough to explain the incredibly complex, structured output they eventually produce.
Correct. If the input, the environment, the experience is insufficient to determine the output, which is the final state of their I-language, then the child must come pre-equipped with much of the structure already in place.
And that innate structure is universal grammar.
Yes, UG, it acts as a genetically fixed, hardwired template or agenda for development. This rationalist position assumes that mental organs grow through a process called canalization channel development, much like an embryo develops organs. It's not something learned through generalized external trial and error.
Which is a sharp contrast with the empiricist view, that the mind is a blank slate at birth and language is just learned through experience.
A very sharp contrast.
So now we move to the concept that ties this rigid, deterministic internal system to our unbounded external experience. The creative aspect of language use.
This is a point that Chomsky draws heavily from 17th century rationalist philosophy, especially Descartes and Humboldt. It's an old observation, really, about what language use truly means, and it has 3 core elements. First, there's freedom from causal antecedents, which just means stimulus freedom. You can think or say anything without regard to what's happening around you or inside you. Second, unbounded flexibility, which is the sheer innovative capacity to create infinite expressions from a finite set of tools.
And third,
And third, coherence or rationality. The sentences we produce are almost always appropriate to the circumstances, even when they're totally novel.
That seems like a profound paradox. How does a deterministic biological computational system and organ give rise to free, novel, and coherent action?
And this is the crucial separation. The computational system is a modular, automatic process. It generates the infinite array of hierarchical thought structures. It gives us the resources.
But it doesn't control how we use them.
Exactly. The use of those resources is what we call free action, and that action is not determined by the computational system itself. And because that action is extremely complicated, it involves volition, consciousness, social context, the science of language must focus only on the nature, development, and operations of the deterministic language organ, the I language.
So to do science, you have to carve out the deterministic biological core and, for the moment, ignore the messy application of it.
You absolutely have to. The moment you start trying to incorporate free action pragmatics, decision-making, social context into the definition of the language organ itself, you leave the realm of natural science.
Which is why Chomsky views fields that study language use, like pragmatics, as maybe impossible to treat as a natural science.
Because human action itself may be beyond the reach of deterministic scientific inquiry. We can study the resources, but maybe not the free will that uses them.
Let's talk about the mechanism that makes this whole infinite system possible. Merge. This is arguably the most radical and foundational claim of the minimalist program. What is it exactly?
Merge is the hypothesized fundamental operation of the narrow syntax, the core computational system. And the goal of the MP is to define it as the simplest computational step you could possibly imagine. It takes two mental objects, let's call them X and Y, and it just constructs a new, larger mental object, the set XY.
That's it.
That's it. It's a mechanism for set formation, but it's applied to mental representations.
And this operation, in its stunning simplicity, is the source of what's called discrete infinity, which is unique to human language.
Precisely. If you can combine X and Y to make a new structure, let's call it Z, you can then combine Z with a new element, W, and on forever. This is what generates unbounded hierarchical structure, the core feature of human language, also known as recursion. The sources argue that merge alone might be the entire language-specific genetic contribution we inherited.
This claim gets enormous explanatory power when we look at how it connects language to mathematics. I know this was a major point of discussion in the book, providing this simple, non-selectional explanation for a really old biological problem.
This is where the systems analysis really pays off, It addresses a dilemma that profoundly troubled Alfred Russel Wallace, the co-discoverer of natural selection.
Wallace was baffled by math.
Totally baffled. He recognized that our capacity for abstract mathematics couldn't have developed through standard natural selection because, well, while everyone seems to have the innate capacity, it was only ever used by a tiny fringe of people and only in very recent history.
So it provided no survival advantage for the vast majority of our ancestors.
None. So it must be an offshoot of some other strongly selected trait, and he strongly suspected it was language.
And merge provides the structural, elegant explanation for that connection.
It does, through a slight restriction of the merge operation. So think of merge as taking two things, X and Y, and putting them together. Now, imagine you have a very simple single thing, which we can just call 0 or a unit.
Okay.
If you restrict merge to only take that single unit and merge it with the structure that already contains it, you get the set containing 0. Do it again, and you get the set containing 0. And again, that is the direct representation of the successor function. That's the core mechanism you need to generate the natural numbers. Exactly. The operation of combining an element with the structure it's already a part of is logically one of the only two possibilities merge allows. This restricted operation, which gives us the natural numbers, it just flows automatically and simply from the core computational principle of language.
So it solves Wallace's problem. Mathematics is a pure spandrel, a side effect of the language engine.
A stunningly non-selectional explanation, yes.
That's fascinating. So if merge is the minimal core of universal grammar factor 1, how do we account for the stunning diversity of human languages? That's where the three factors framework comes in, and it radically simplifies how we view variation.
Right. To move beyond just describing language structures and ask the deeper explanatory question, why does UG have the properties that it has? The minimalist program systematically considers three factors that shape the final I language.
Factor 1 is UG.
Factor 1, as we said, is UG, the language-specific innate genetic contribution, which is potentially just merge. Factor 2 is experience. The input data from the environment that sets minimal parameters, like choosing mosquitoes' specific sound system and word order over French's.
And factor 3 is the one that breaks the traditional bounds of linguistics entirely, and it removes this huge conceptual burden from genetics.
The third factor. These are principles that are independent of the language faculty, the organism, or even biology. These are universal constraints. Physical laws, general computational efficiency, mathematical simplicity, and constraints on developmental processes.
So things like how crystals form or how an insect navigates using minimal resources.
Exactly. The realization that highly efficient computation and physical constraints might determine much of language structure means linguists don't have to assume a massive, complex, historically accidental genetic code for every single rule.
And this seems to be the core philosophical engine of the minimalist program, this search for perfection.
It is. The value of the third factor is that it allows the MP to investigate if language is, in fact, perfect, meaning optimally designed to meet the necessary conditions imposed by the two interfaces. The conceptual intentional interface, which is thought, and the sensory motor interface, which is sound or sign.
And this is a sharp contrast to the view that language is just an inefficient kludge, a result of millennia of historical accidents.
Yes, what the biologist Francois Jacob called bricolage, a system that looks jury-rigged or thrown together, the MP hypothesizes the exact opposite, that language is elegant and simple, like atomic structure.
Okay, let's transition now to a systems mapping analysis, beginning with the language faculty as a biological system, the organ hypothesis. This approach seems to mandate certain conclusions about modularity.
So the field of biolinguistics assumes the language faculty is an organ that grows or develops according to predictable genetic and natural constraints. That's canalization. It's not something you train a child to do, like riding a bike.
It's something that happens to the
It
child.
happens to the child, like puberty or learning to walk.
And this idea of modularity is strongly supported by that sudden evolutionary timeline we talked about earlier.
Yes. The sudden saltational introduction of language in a small breeding group implies the core system has to be simple. A system that requires a long, complex history of random genetic accidents, a bricolage, is just ruled out. This necessity for simplicity and sudden expression is what ultimately drives the minimalist program's quest for perfection.
And we also have clinical evidence, right? Reinforcing the idea that the core system is modular and independent of its peripheral output.
Absolutely. This goes back to the early discoveries by Eric Lenneberg in the 1960s. Lenneberg observed children with severe motor control difficulties, a condition called dysarthria, meaning a lack of control over their articulatory systems, who nonetheless had full native language capacity.
So they could think perfectly, understand complex grammar, even if they couldn't physically speak clearly.
Exactly. This is the clearest demonstration of the competence-performance distinction.
It separates the underlying I-language system, competence, from the sensory motor systems that externalize language, which is performance.
It does. Lenneberg's findings were dramatic because they showed that the core system is largely independent of these peripheral systems. You can have a perfect language organ, even if its external speaker system is highly defective. And that just reinforces the view that the essential function is internal.
Let's return to merge, but now let's analyze its two systematic functions, external and internal. This distinction is necessary to explain how language can both build basic meaning and handle complex discourse.
Okay, so external merge is the simplest form. It's the concatenation of two distinct elements, x and y, to form xy. Its primary systematic function is to generate argument structure.
The basic thematic relationships, who does what to whom.
Exactly. This is how we build the core meaning. John saw Mary.
But natural language, unlike programming languages, is defined by its ability to move elements around, displacement. And that's where internal merge comes in.
Precisely. Internal merge is the mechanism for displacement or movement. It takes an element, x, that's already constructed inside a structure, y, and it copies it to the edge of that structure. So you get x.
And logically, if all structure is built by merge, this is the only other possibility besides external merge.
It's the only other possibility. And this property, displacement, was long considered this kind of awkward imperfection of language. I mean, why waste resources copying and moving elements around?
But the MP suggests it's not a flaw at all, but an inevitable feature.
It turns out to be computationally inevitable. It effectively comes for free unless it's explicitly blocked by some external constraint. And its functional role is entirely different from external merge. Internal merge is necessary for generating discourse-related information.
Can you give us an example of that functional role?
Sure, think of what questions. If you start with the structure John bought a book and you want to ask what did John buy, the word what moves from its internal position after buy to the beginning of the sentence to the edge. This movement, which is powered by internal merge, is crucial for expressing discourse properties like focus, topic, scope, and relating new information to old information.
So you have this systematic distinction: external merge for argument structure, internal merge for discourse properties.
And that's highly suggestive that the system is optimally designed or perfect because both of the structural possibilities that are inherent in merge are put to optimal cognitive use.
Moving on to methodology. This is where the book really challenges a lot of conventional approaches, especially in the social sciences. Let's map the incentive structures that shape scientific inquiry, specifically contrasting Chomsky's approach with data-heavy methods. This is the idea of Galilean idealization.
Right. The natural sciences, physics, chemistry, they progress by choosing to ignore the messy complexity of the real world and constructing idealized situations to find underlying principles.
Galileo is the classic example.
He is. He studied a ball rolling down a frictionless inclined plane, which of course doesn't exist in reality. The whole goal was abstraction. The aristocrats funding him, they wanted him to study flowers growing, which was complicated and relevant. But Galileo knew that only by idealizing and simplifying could he find the basic predictive principles of motion.
But doesn't ignoring 90% of observed English data mean you're studying a hypothetical language that doesn't really exist? That's the core challenge from empiricist or data-driven linguists. How does Chomsky reconcile that anti-data stance?
Chomsky argues that this is the necessary methodology of any mature science. The alternative is just intellectual paralysis. I mean, consider physics today. Scientists don't throw out the theory of gravity because they can't find 90% of the universe, dark matter, and dark energy. That failure to explain the surface data is seen as a scientific problem that needs solving, not a reason to abandon the entire theoretical framework. Yet, in some areas of social science or non-Galilean linguistics, if a theory fails to account for a big chunk of the messy real-world data, the theory itself is immediately dismissed.
So the incentives are inverted. In physics, you look for a simple explanation for complex phenomena. But in data-oriented fields, the incentive is just to gather more and more complexity.
Exactly. The incentive in a mature science is to simplify and idealize. Think of Boltzmann fighting for the reality of atoms, these things that were invisible to the naked eye. In contrast, fields like corpus linguistics, and by extension, modern large language models, are characterized by what Chomsky calls the throw the computer at it approach.
Just collect massive amounts of surface data and run statistical correlations.
And hope some pattern emerges, but without first constructing a principled, simple theoretical framework. It's a methodology that was largely abandoned centuries ago in physics and chemistry because it just lacks explanatory depth.
So it's the difference between trying to understand the blueprint, the I language, and trying to perfectly record every single nail and paint splatter on the finished house, the E language.
That's a perfect analogy. An awful lot of what you find in any language. The historical shifts in pronunciation, the influence of other languages, the acquisition of specific accidental vocabulary is the result of historical accidents.
Like the Norman Conquest.
Like the Norman Conquest's deep effect on English. These facts tell us nothing fundamental about the innate language faculty that evolved tens of thousands of years earlier. To do science, you have to abstract away from the historically messy surface data and focus on the internal system.
Let's look at the crucial feedback loops now. How this innate language system shapes human thought and inquiry itself. We've established that merge enabled complex thought.
That's the first loop. The capacity for hierarchical planning, detailed interpretation, complex thought, all of it powered by merge, that led to the explosion of culture, art, and complex social structures 60,000 to 100,000 years ago. Merge gave us the resources to think infinitely, which allowed us to survive and thrive.
And the second loop connects the structure of the language system directly to our ability to do science, our science-forming capacity.
This is a really deep connection. The innate system that seeks simplicity, unification, and coherence when it's constructing linguistic structure is plausibly linked to our science-forming capacity. This is what the philosopher Charles Sanders Peirce called abduction.
Which is?
It's the ability, which seems to be unique to humans, to miraculously converge on the best explanation from a logically infinite array of possible hypotheses. This capacity, driven by principles of simplicity and non-redundancy, it seems to be intrinsic to our nature as specific biological creatures. Our minds are just structured to prefer elegant solutions.
So the same innate biological drive that makes our grammar simple is the one that allows us to discover the laws of physics. And this brings us to the fundamental paradox. Biological limits enabling cognitive freedom.
The internal system, the I language, is constrained, it's modular, it's highly computational, it is limited. It imposes these strict rules like the hierarchical structure required by merge. But it is this very constrained deterministic system that provides the fundamental unbounded resources for free action.
The ability to use language to create science, to ask deep philosophical questions, to plan for a non-existent future.
To interpret the world, the biological limits of the language organ are the foundation of our external cognitive freedom.
Let's move to the present-day implications, starting with modern linguistics and cognitive science. What has the minimalist revolution structurally accomplished in the last few decades?
Well, the MP has been successful in eliminating a lot of theoretical baggage from earlier theories, like the strict division between deep structure and surface structure. And it did that by focusing relentlessly on computational economy. By prioritizing elegance and efficiency, the theory of core grammar is getting simpler, not more complex.
Which aligns perfectly with the prediction of the third factor, that universal constraints dictate optimal design.
It does. And this search for simplicity has radically altered how linguists view language variation across the globe.
How so?
Previously, the principles and parameters approach suggested that all language variation was contained within universal grammar. So UG had these switches or parameters that a child would set based on their language input. That was factor 2. Now, the view is shifting. The core computational system, or narrow syntax, may be almost entirely uniform across all human languages.
So where does all the variation come from?
Most parameters, both macro and microparameters, are now thought to reside in the mapping to the sensory-motor interface, the PHON system.
So that shifts all the messiness of human languages, the different sounds, the dialects, the historical drift out of the core mechanism and into the peripheral system.
Absolutely. The PHON interface, the system responsible for externalizing thought as sound or sign, is messy, it's variable, it's learned. It is subject to historical changes like the Norman Conquest and cultural variation. The core syntax, the meaning-generating engine, is hypothesized to be pristine and universal.
Which means that the diversity of human languages primarily reflects how different cultures have chosen to externalize the same core internal computational structures.
That seems to be the direction things are heading. And the computation for meaning itself seems to operate outside of time.
What do you mean by that?
Well, evidence is accumulating that the computation mapping to the conceptual intentional interface, the SIM, the meaning interface, doesn't rely on linear ordering. Everything may happen simultaneously or in parallel. Linear order is only necessary for externalizing sound or sign because our mouths and ears operate in time.
Which further reinforces the idea that externalization is a peripheral system, while the essential function of language is internal hierarchical thought.
Exactly.
We have to address the profound implications for artificial intelligence and machine learning, which generally operate on principles that are directly opposed to Chomsky's rationalist nativist framework.
Yes. Chomsky expresses deep skepticism, even a sort of lack of interest, for approaches like corpus linguistics, or the statistical methods that underpin current large language models, or LLMs. He sees them as prioritizing massive data collection and statistics over constructing fundamental theoretical principles.
So he views it as methodologically regressive. It's like throwing out Galileo's frictionless plane in favor of collecting endless data on how flowers grow.
That's a good way to put it. The contrast for him lies in the nature of the object being studied. Human natural language, the biological object, is inherently different from formal languages like programming systems or quantification theory, which are human inventions.
How are they different?
Well, formal languages consciously constrain themselves to use only external merge. They actively block the troublesome movement-generating internal merge. But natural language, the biological object, makes internal merge mandatory and computationally free, precisely because it's governed by those third-factor constraints, aiming for optimal design.
So AI can replicate the behavior of the simple invented formal languages, but it struggles with the complexity and hierarchical depth of the evolved biological object.
Precisely. And beyond that, there's the computational barrier for acquisition. The process of trying to find the optimal instantiation of grammar from raw data alone is computationally intractable. It's just too complex for a human child or even a sophisticated machine to evaluate all the grammatical possibilities efficiently.
And this complexity argument just reinforces the necessity of innateness.
It does. It reinforces the need for UG and merge to automatically channel development toward a possible human language, suggesting that simple statistical correlation can't be the acquisition mechanism.
Shifting to debates on creativity, intelligence, and consciousness. How does Chomsky's framework characterize the nature of meaning or semantics?
Chomsky maintains that linguistic semantics is really a form of syntax. It's the study of the internal properties of mental symbols, he calls them I concepts, and how they combine compositionally.
So what about referential semantics? The tricky problem of how words map to the world.
That's relegated to pragmatics, which is free action and may be fundamentally beyond the reach of a natural science. When we speak of a word like cat or river, we are talking about complex I concepts inside the head, not external entities that perfectly correspond to a single physical object.
And the book makes a crucial distinction here between two types of human innovation and concept formation.
Yes. There is scientific concept formation and there is linguistic creativity. Scientific concepts like gravitation, atom, or gene are radically counterintuitive. They're counter to common sense. They're introduced by a specialized science-forming capacity that consciously seeks principles that reject surface reality.
And linguistic creativity.
Linguistic creativity, which is enabled by merge, is primarily compositional. It takes the available concepts, often common sense, innate concepts like water, house, or chase, and it combines them infinitely to generate unbounded expressions. The latter is about structure, the former is about truth in the external world.
Does this mean the language system is the single, all-purpose central processor of the brain, as some theories like the language of thought have suggested?
Chomsky is cautious here. While language may well be the system that binds other cognitive modules, vision, audition, social systems together into complex thought, it's unlikely to be the single central processor.
Why not?
There must be other non-linguistic mechanisms coordinating fundamental sensory systems. Things like integrating sound and smell, or managing basic motor functions that operate independently of the linguistic system. Language provides the resource for complex planning, but it isn't the sole operating system for the entire brain.
Finally, let's discuss the social and ethical implications, particularly in education and theories of mind, which often involve this clash between rationalism and empiricism. And the sources, they pull no punches when critiquing the empiricist position.
Well, the rationalist position assumes that fundamental capacities like language, mathematics, and even morality are predetermined and innate, lodged in a fixed human nature.
Which suggests that only certain social structures are biologically possible.
And that the inquiry into this fundamental human nature is the path to understanding the good life for humans.
I have to push back here, as this is a very charged political statement in the sources. What is the critique of the opposing view empiricism, which emphasizes total plasticity and environmental shaping? Why does a source label that framework basically totalitarian?
The book argues that empiricist theories, which assume the mind is highly malleable or a blank slate at birth, are often psychologically and socially attractive to intellectuals who want to be the managers or trainers who design and shape others' environments, especially in children's education.
So if the mind is infinitely malleable,
Then those who control the environment gain total control over the outcome.
so the critique isn't about the philosophy of knowledge itself, but the social danger of the hidden assumption of control that's inherent in radical environmentalism.
Precisely. If one assumes total plasticity, then the potential for manipulation is vast, and the powerful have the pretext to argue that the limits of human possibility are defined only by the structures they impose. And this contrasts sharply with the rationalist view, which grounds human freedom and moral capacity in a fixed, universal, and innate biological nature.
And this fixed nature, according to the source, extends beyond cognition and into morality.
Chomsky posits that a moral faculty, much like the language faculty, is universal and lodged in a fixed human nature. Just as UG channels the acquisition of language, this moral faculty gives rise to universal moral principles, like justice, fairness, and compassion.
Which directly challenges the relativistic view that concepts like justice merely track power or social consensus.
It does. The existence of these innate faculties is what allows us to exercise human freedom and make coherent, universal judgments about right and wrong, even across vastly different cultures.
Moving to broader themes, let's connect these findings back to our core concept of systems and structure, starting with the constant tension between simple systems and messy surface explanations.
The struggle of biolinguistics really mirrors the struggle of physics. We're reminded of Galileo studying his idealized systems, or Boltzmann fighting for the reality of the atom. Biolinguistics studies the I language, this invisible, real internal system of computation, even though all we can observe externally is the messy, variable performance, the E language.
So the key is trusting the elegance of the simple system over the complexity of the observed data.
Correct. A huge amount of observable data. The surface forms, the accents, the specific lexicon, the historical impact of the Norman conquest, all results from historical accidents and performance systems. And these tell us nothing about the fundamental innate language faculty. To construct a robust natural science, you have to embrace idealization and abstract away from this messy surface data to find the core, simple, predictable mechanism.
Next, let's map the hidden structure that's beneath our everyday linguistic experience, focusing intensely on the difference between the crucial hidden structure, which is hierarchy, and the superficial structure, linearity.
The absolutely crucial structure in language is hierarchy. It's created by merge. Merge takes elements and nests them inside sets, creating these deep structural relationships that determine meaning.
And linear order.
Linear order, conversely, is merely an artifact. It's imposed by the sensory motor systems, which have to output sound or signs sequentially over time. The mind's core computational system may operate in parallel, without any inherent linear order at all.
So the brain doesn't care if we say John saw Mary or Mary saw John structurally. It cares about the hierarchical relationship, the verb structure, the argument structure, and then the peripheral systems impose the time sequence.
Precisely. The core system operates in 3 dimensions, but the externalization system flattens it into 1-dimension time. And this hierarchical structure is what explains complex linguistic phenomena like C command.
C command sounds deeply technical, but you're saying it flows automatically from the geometry of merge.
C command is a dominance relation in hierarchical structures, and previously it was treated as a primitive, a rule you just had to assume was innate. The minimalist program aims to show it's not a primitive. Instead, concepts like C command flow naturally and inevitably from the geometry of merge, specifically internal merge.
How does that work?
By copying a moved element to the edge of a structure, that new highest element automatically commands or dominates all the other elements within that structure. It's an efficient geometric outcome of the simplest possible operation.
That structural insight is incredibly elegant. The final thematic connection links these findings back to our existence as biological creatures. The biological limits shaping human possibility.
Chomsky argues that because we are biological creatures, our science-forming capacity has innate, investigable, epistemic limits. We are not omniscient. And unlike Kant, who thought these limits were beyond human definition, we can actually investigate them.
How?
We proceed by seeking simplicity, unification, and avoiding redundancy, because that is simply the best that we can do given the specific finite design of our biological nature.
And accepting these biological limitations is, paradoxically, what makes science possible and successful.
Absolutely. The assumption that humans possess a universal device capable of solving every problem or posing any question is just incoherent. We are not gods. We are finite biological systems. The success of physics and linguistics comes from lowering our sights, idealizing the subject, and focusing on simple, isolable subsystems.
Just like Galileo focused on his inclined planes.
Exactly. Science is successful precisely because our cognitive resources are limited and channeled by instinct, such as merge, which gives us a preferred pathway for generating and evaluating hypotheses.
Here's where it gets really interesting. The rigorous pursuit of simplicity is simultaneously revealing the profound biological limits that make human existence, and indeed the entire enterprise of science, possible. The constraints are the creativity.
It is the most beautiful irony of the theory.
Let's conclude by reflecting on what this deep dive helps us see differently about ourselves.
First and foremost, we have to radically reject the common sense view that language is primarily a tool for external communication or an arbitrary social invention.
Instead.
Second, we have to adopt the highly constrained scientific view that language is a simple, near-perfect, internal computational system merge that spontaneously generates infinite structure, providing the singular biological foundation for human thought and our unique cognitive capacities.
And the staggering messiness we observe in the world, all the different languages and dialects.
The messiness, The vast differences in sound systems, the dialects, the historical drift, the communicative ambiguity is largely due to the peripheral performance systems, the PHON system, that are required to externalize this perfect internal structure. The chaos is on the surface, the order is within.
Why does accepting these biological and computational limits ultimately strengthen scientific understanding?
Because the minimalist program, driven by this search for efficiency, has shown that much of language structure may be determined by third-factor constraints, universal laws of nature, and efficient computation, rather than by complex, highly specific genetic code.
And accepting these constraints allows us to progress beyond explanation.
We move from just explaining how language develops in an individual to asking the deeper question: why did nature make language this way? It integrates linguistics with physics and biology as a seamless part of the natural world.
What crucial questions remain open or perhaps unknowable, even with this revolutionary, elegant framework?
Well, there are huge gaps. We still have no clear idea about the nature of the core conceptual atoms, the lexicon that merge combines. We know they're rich and universal, but what does it mean for the concept of house or river to be innate? And how do they relate to the underlying neurological reality?
And there's the translation problem.
There is. How exactly does the nominalist language of sets and computation, like merge, translate into neurologically realizable components in the brain? This connection between computation and neurology remains a major scientific challenge.
And finally, the question of free human action remains unsolved.
Can the use of language pragmatics, free action decision-making, moral judgment ever truly be captured by a natural science that seeks deterministic causal principles? Or is this the domain where the non-deterministic, conscious nature of human agency resides? Chomsky posits that this may be a problem that our own limited science-forming capacity cannot resolve because we are attempting to look at ourselves from a perspective we are biologically constrained from accessing. The final provocative thought for you to consider is this: the same simple, elegant computational system, merge, that enables abstract mathematics and the capacity for physics, also grounds the very concept of justice and the moral imperative to challenge power structures, suggesting that the biological constraints that generate language may ultimately dictate the range of human possibility, both intellectual and moral.
Our deep dive today was based on the insights found in The Science of Language, Interviews with James McGilvray by Noam Chomsky. We encourage you to read the book yourself to explore these challenging ideas further. Support the authors if you found their ideas valuable, or check your local library for free access. This project is free and publicly accessible. If you'd like to support the time, tools, and research behind crisis and perception, you can become a supporter on Patreon. For a shorter, visual overview of this topic, see the mini explainer linked in the description. If you enjoyed this kind of systems-level analysis, please like, subscribe, and comment with books or topics you'd like us to explore next.